Hello everyone. Programming Stable Diffusion SDXL using the Diffusers package can be intricate, particularly for those intrigued by generative art. But fear not. If you're enthusiastic about exploring new horizons in generative art, we've got the perfect solution for you. In this YouTube video, we'll walk you through the process of programming Stable Diffusion SDXL using the Diffusers package, opening up endless possibilities for your creative projects. So, if you're ready to infuse your generative art with the magic of Stable Diffusion, stay tuned and let's embark on this coding adventure together. In the last video, we talked about the pipeline of the generative models from Stable AI. If you have not watched the video, you can find the link here, or in the description below. Today, we will talk about another way to program the Stable Diffusion XL. We will see how to do the Stable Diffusion programming using the Diffusers package from Hugging Face. Like the last video, we will look inside the pipeline of the Stable Diffusion XL. Actually, the steps we needed were exactly the same. We need to create all neural network components, setting up all contexts and embeddings, create the initial latent, repeat the reverse process. Do the classification-free guidance. Subtract the predicted noise from the latent. And finally use the VAE to decode the latent into an RGB image. This is the SDXL pipeline. Usually we will have the latent and the prompts. And then repeating the U Net forward function. We may skip the refiner step and go to the final VAE decoding step directly. We will talk about this path today. Like the generative models from Stable AI, Diffusers use a config file to specify all the components. You can find the configurations from the model index.json file. You can see that there are a U Net, 2 tokenizers, 2 text decoders, and 1 VAE component. These are the components that we will create. It is straightforward to create all of these using Diffusers. All we need to do is to set the model key. Then it will download all the config files and wait for us. If we print the U Net from the pipe object, we can see something like that. It shows all the modules inside the U Net module. There are some embedding modules, some down blocks, a middle block, and up blocks. However, in Diffusers, there are only 3 down blocks. The first block in Diffusers represented the 3 blocks in the SDXL U Net diagram. Hey there! If you're enjoying the content so far, make sure to hit that like button, and subscribe to our channel for more videos like this. By hitting that subscribe button, you'll be the first to know when we release new videos. Don't forget to turn on notifications as well, so you never miss out. The second block in Diffusers represented the 3 blocks in the SDXL U Net diagram. These 3 blocks are defined by the third Diffusers down block module. After all the components are created and initialized, we can just call the pipeline to create the image for us. We need to input the positive prompt, the negative prompt, the CFG scale, and the steps we needed. It will then generate the image for us. It is straightforward to use. If we look inside the pipeline, the first thing it will do is to create the embedding. The positive and negative prompts will be used to create the prompt embed. There are 2 text encoders in SDXL. The first and second text encoders will create the prompt embed with the shape. That is for the cross attention. The second text encoder will also create another pull prompt embed with a shape. That is for the label input. Inside the forward function of the U Net, it will set a few more embeddings. The text embeds are from the second text encoder. The time embed is the combination of these 3 inputs. The final add embed is the combination of the above 2. That is the label input for the U Net module. Inside the pipeline, it will create a latent to start the reverse process. If we want to have a 1024 x 1024 image, the latent size will be 4 x 128 x 128. This is the loop to repeat the process. If we have a CFG scale, the latent will be double in size. Inside the loop, the U Net forward function will be called. This is the forward function. What it was doing was going through all of its modules. After we get the predicted noise from the U Net, we will do the CFG operation. This value is the CFG value. After we did the CFG, the pipeline will use the scheduler to subtract the noise from the input latent. The results will be another latent, but with less noise. After repeating all the steps, it will use the VAE to decode the latent into the final RGB image. This is the output. It is the same as the last video. Observations. The Diffusers package is very easy to use, and it is easier to understand. The steps are straightforward. The SDXL Web UI extension was also made by using the Diffusers package. Conclusion. This is another video log for learning about the Diffuser package. If you are a programmer, I hope it will be useful to you. Whoa! If you have any questions or suggestions, please let me know in the comment below. Thank you very much. If you enjoyed this video and want to learn more about Stable Diffusion and LoRA training, hit that subscribe button and turn on notifications so you never miss a video. I will put up the other video soon. You can also find all the models and images in my Patreon account. The link can be found in the description. Thank you and see you in the next video.